Okay, so good evening, everyone. Am I audible to everyone?
Yes.
Yeah.
Yes. Okay, so today's session is today is the day one of our bootcamp, and the session is on the basics of climate change. So, एक second.
Abha, you can share from the Canva itself. There is a button called present.
Already present करियो. I think one of my slides has gone little haywire. Doesn't matter. So, ठीक है. So the structure of the presentation will be like this. We will start first with weather. And in case some of you has got any doubt as I go on to the presentation, don't hesitate to interrupt, because if you miss out here, either you note down and then we discuss in the evening at the end of it, or if you think that you can you are unable to understand something, you can interrupt me in between also. Okay, so we start with weather. What are the causes? From weather we change on to climate. Why climate is important? What is climate change? Causes of climate change. Then how does human activity they come in, the anthropogenic influences. We'll briefly cover the concept of planetary boundaries and the interactions that take place when we talk about the Earth system approach. And at the end, the last segment, I'll cover modeling the climate system. I will not go too deep into it because climate modeling itself is a specialization, but I'll briefly give you an overview. Okay. So when we start with what is weather, so generally weather is defined as the state of our atmosphere at a specific place at a specific time. So for example, if I say that, what is weather of Delhi today at 4 o'clock in the evening, or what was weather of Delhi yesterday at 9 o'clock in the morning. So if you can see here, I've given, don't get too bogged down. It's a coded form of weather, which is usually used in because there are too many variables involved. So what you do is you code it and then you transmit it. So I just want to tell you what are the elements. So VIDP is Delhi. So basically the location, which place, we are talking about weather of which place. Then it is 13th of December, 10:30 Zulu. Zulu is the universal time coordination. If I think people who worked internationally, or when we try to align the timelines, UTC, the universal time coordination is the standard time that we use. So it is at 10:30 UTC. India, for that matter, is 0 plus 5:30. IST time is about 5:30 plus of Zulu. Then,
I think your screen presentation is not visible.
Abha, share this.
Share नहीं किया क्या मैंने? Share. Okay.
हाँ. No problem.
Stop. अब हो रहा है?
Yes.
You can see now?
You can, right. Awesome.
ठीक है, you can see now? So,
yeah.
Clear ho raha hai abhi? So I'll just briefly go through this also, because visual is, so this is the basic. We start with weather, then climate, move on to climate change, and then human activities, planetary boundaries, and at the end of the session, I'll cover the modeling part. Now, when we talk of what is weather, so it is at a specific place at a specific time. So the elements, look at the elements. So you have one location. So we're talking of one place on a particular date and time. Then what are the elements of the weather? There is wind. So it is 10005 knots. It means from, it is, if you're aware of that 360 scale, so it is coming from 100 degree direction, and the speed is about 5 knots. So wind has got two components, direction and speed. And when we later on come up why weather becomes important, because even in terms of infrastructure projects, wind becomes very important. Then another element is visibility. Then whether there's any significant weather, like here HZ is used for haze. So what are the significant weather? You can have rain, you can have drizzle, you can have snow, depending on which part of the world you are. What are the climatic conditions there? Visibility differs. Thunderstorm, thunder shower, lightning, these are all significant weather. Then we have cloud cover. Cloud cover is generally reported in multiple layers. So you have low clouds or medium clouds or high cloud. We also report temperature. I've written DB and WB. This is dry bulb and wet bulb. These two temperatures are used basically to calculate the humidity also. And then you have, I think my screen is,
what happened?
Just 1 second. Weather, and then you have the pressure element. So these are the elements they basically combine. So you have wind, visibility, clouds, temperature, significant weather, and pressure. They together comprise the weather of one particular place. Now, what causes weather? Matlab, you must have read in your basic school sciences also what causes, because the earth is tilted at an angle of 23.5 degrees. So there's a tilt of the earth, and because of the tilt of the earth, there's differential heating. There's different heating at different latitudes. Otherwise, had there been no tilt, the poles would have been totally cold and the equatorial region would have been totally warm, and the circulation patterns would have been very different. But because of the tilt of the earth, it's tilted 23.5 degrees. So you have differential heating varied, which is governed by basically the latitude, and that differential heating causes the differences in air pressure, temperature, and moisture. We've seen the elements of the weather in the previous slide. So it changes the pressure, it changes the temperature, and it changes the moisture. And because of that, what happens is that, the major heating that takes place at your equatorial region, the colder regions are there at the poles, but your earth is also tilted. You have differential heating because of the latitude. So what happens is if you can recall, or all those who come from the sciences background, you had laws of thermodynamics. If you have differential temperature, then heat will always flow from higher temperature to lower temperature, so that it tries to balance out. Same heat is shared by the whole body, and earth is a closed system in itself. So basically, heat transfer has to take place from the equatorial region to the poles. So northern hemisphere mein northwards, southern hemisphere mein southwards, and that results is, this is what idealized earth should have been. But the circulations are not only along the surface, they're also along the vertical. So you've read about different, I will not go into the details, different layers of the atmosphere. You have troposphere, and then mesosphere, stratosphere, ionosphere. So that circulation is in the vertical. It's a three-dimensional circulation, and this circulation is basically for heat transfer. The basic reason is, if you take out the tilt of this earth and you take out the sun, there'll be no weather. So that is the basic science of it. So you have basic transfer of heat from the equator to polewards through general circulation model. Now, the transfer of heat is not only through the atmosphere, the transfer of heat is also through the ocean. In fact, oceans are one of the major sinks when you talk about absorbing heat. Now, this is again going back to your 12th, I don't know which class, senior secondary sciences. The transfer of heat, what you can see here in the lighter pink shades and yellowish shades are the hot water currents, and which are on the upper level of the ocean. And the blue currents that you see, these ocean currents are at the bottom of the oceans, and they carry cold and saline water. So that there's a huge circulation. It is called thermohaline circulation. Thermohaline, break it into two. Thermo means temperature. Haline means, it's basically a word that is derived from saline. So because ocean is saline, and as the temperature changes, the salinity of ocean changes. Because of the changes in salinity, the density changes. Because of the changes in temperature, the salinity changes. So there are various factors. So the transfer of heat, because as the earth's atmosphere, the earth, as you see, you have land body, but that is only 1/3. The rest is all water mass. So the transfer of heat is through air, the transfer of heat is through oceans, and that is through thermodyne circulations. Okay. Now, this is when we talk about heating, the tilt of the sun, the tilt of the earth, and the incoming solar radiation that causes weather. Now, when we talk of climate, what is climate? If you average out weather over a period of time, that becomes climate. What do you mean by averaging out? Say, suppose I say over Delhi. Usually climate is not of one particular place, climate is of a region. Why? Let me go back to this slide, because you have regions. Equatorial regions are the most, they receive the most incoming solar radiation. Tropics have got higher incoming radiation. The last, around 30 degrees to 6, the temperate region has got lesser incoming solar radiation. So because of this, that particular region has got a certain pattern of heating. So that region has got a particular climate. So climate basically is dependent. Climate is not, I'll not say what is climate of Delhi. I'll say what is climate of North India. Even in North India, say what is the climate of North Indian plains, or what is the climate of North Indian Himalayan region. So the terrain and the location, altitude, all these parameters. So usually when we talk of climate over a region. So it is the long-term pattern of weather over an area. So how do you calculate the long-term pattern? Now, because of the tilt, you have seasonal variations and you have diurnal variation. Diurnal variations means within a day. So you have minimum temperatures, the coldest temperatures in the morning. Then as the sun angle goes up, you have maximum temperatures coming somewhere around 2:30 in the afternoon. Then again, the the sun, earth starts losing radiation, you have lower temperatures. So these are diurnal variation, the one changes that take place during the day. Then you have seasonal variations, because your sun angle changes, so the sun goes to the southern hemisphere, you have winters in the northern hemisphere. So what you do over a particular area, you calculate the averages over a period of time, how the weather is over this particular time period. Now, how do you calculate averages? Those averages are calculated for each element, the element that fits in. These averages are calculated for wind, they're calculated for temperature, they're calculated for visibility, they're also calculated for pressure, dry bulb, maximum, minimum, humidity. So all these variables are averaged over a period of time. So I'll go back and to this slide again. So your wind averages are calculated, visibility averages, cloud averages, temperature averages for particular time. So say if you know about weather observation, a weather observation is taken every half an hour. So every half an hour. So just to give you about the quantum of data that I'm talking about, Delhi observation is taken every half an hour. It means in a day, Delhi has got 24 into 2, 48 observations. That is for one day. You have 365 days in a year. So those are the multiplied by 48 into 365. Then you have, for 1 year, you have these many observations. So when you want to calculate the average climate over that particular region, what you'll see is you calculate all these variables, average them out. What is the time period that you take for averaging? The time period you take classically for climate is 30 years. So less than 30 years, we'll talk about decadal variations. We will not term it as climate. So if I have to calculate, if I have to see, we say climate is changing. So statistically, how do you say climate is changing? So you say from 1950 to 1980, if I take the average of the weather parameters, I find that the average temperature was this, the average maximum temperature was this. Now, if I change my data set, I take from 1980 to 2010, that is another 30-year period, I find that the averages have changed. So I say if the significant change in the averages, statistically significant difference is there, then we say the climate has changed. So the minimum period that you typically use as prescribed by the World Meteorological Organization is 30 years. Why is climate important? Why do we say, climate change itna bada debate hai? I will not go back to the basics because it impacts every aspect of our life. You talk of agriculture. Agriculture I'm talking about, say, what do I grow in this particular period, in this particular season? So your agriculture, and dependent on that is your food security, your infrastructure. We have seen extreme weather events, the entire thing gets inundated, livelihoods, health, the modes of transport, various aspects of production, energy production, industrial production, everything is impacted by climate. So we need to know how the climate is going to be. If it gives us surprises, then we are sort of, we are facing the impacts. Now, what is climate change? If you find that the average climate, like I said, you calculate one time block and you say another time block, if you find that there's a shift in the average climate over a long period of time. So we generally, when we talk of climate change, what is our baseline? Our baseline is usually around 1880 when the industrialization started. Or for other emissions claim, we'll see later on when we talk about the international agreements, we'll say we take generally about 1992 as the baseline emissions, and then we talk. So over a long period of time, you see how the averages are changing, how the climate is changing, and there has to be a systematic change in the long-term statistics. It should show, say it is from 0.1 to 0.2, then it is going to 0.6. It has to be a significant change. What are the parameters we're talking about? The variables we're talking about are temperature, precipitation. Precipitation means it includes rain, drizzle, thunder shower, snow, anything that falls from the cloud is precipitation. Then pressure, and wind, which has been sustained over several decades or longer. So if you find in one particular block, you find the average precipitation has gone up, then you find, it is not a significant change. Next decade it has gone down. You'll not say climate has changed. There has to be a significant variation. So if you see that this was how my averages were playing out and for one particular time period, and you find that now your averages have changed. So this is your current climate, this is your future climate. So there's a shift. So your average temperature has increased. So if you look here, your number of hot days will increase, and these are your extremes. These are extreme hot days, these are extreme cold days. So the number of extreme hot days where you have heat waves, they will increase. So there's a shift in your entire average, and because we are in a warming climate, so you're going to see more weather associated with heating world. What causes climate change? Now, what causes climate change is there are two. It is not, say, if we see that there were no humans on planet and we had not industrialized and we were not using fossil fuels, would the weather climate not have changed? Climate changes. There is a natural variability. What are the natural variability? There are certain forcings. I'll not go into too technical details. What are the forces that act? Not literally forces, but what are various external forces that act? So you have changes in solar emissions. So you have every 11 years, you have change in solar cycles. At times you have solar flares. Now, how does it change? Because initially when we started, we say, what are the two factors responsible for weather? One is your tilt of the earth. Another is your incoming solar radiation. You take out sun, there'll be no weather. You take out the tilt of the earth, there'll be no weather. So changes in these, changes in the that cycle is 23,000 years. Changes in the precession of the earth. So how the earth's axis, it changes from 23.5 on one side to 23.5 on the other side. So those, the changes that take place over thousands of years, and because of that, over thousands of years, historically, it has been observed that kahi pe there was a snow age, then it started melting, we were in a warmer climate, then again all those changes. So there's a cycle that takes place. Those are natural forces. But what we're seeing now is our anthropogenic. Again, anthropos is human, genic is induced. So human induced changes are there. And why do we call it human induced changes? Because we have seen significant changes in very short period of times. So natural variability, when we talk of, we are talking of tens and thousands of years, from one snow ice age to warming, and then to another ice age. There are tens and thousands of years. But in the last 1.5 decade, 150 years, we have seen such significant changes in climate, which are not because of natural causes. That is why we say it is anthropogenic change. Now, when we talk of how much, if you look at the magnitude, it's also a question that you can dwell philosophically on. That if you look at the magnitude of the Earth and you look at how small a human size is, then can a human change the global system? And is it within the capacity of a human to change the Earth, or to change, the global circulation models? And Earth atmospheric circulations, that huge jet stream that are playing. There are thermo-aligned circulations. You have Gulf Stream, hot water currents, cold water currents. Is human capable of changing that? Unfortunately, the answer is yes, because the type of interferences that we have done, we have basically changed, we have interfered with certain thresholds. So there's a very famous book, I've mentioned maybe if I find a soft copy later on, I'll provide you a link, Limits to Growth. It came out in 1972, and it dwelled on the idea that our planet has limits on the burden that we play, that the anthropogenic activities, the burdens that they put on Earth. What are the burdens that we're talking about? World population, population explosion was a term. In fact, all those who have been born within this century would not know, but the 1980s and 1990s, this word population explosion was used very rampantly, because the world population was increasing, the rate of growth were very high. And then in 2000, by 2000, they realized, we need to control the population also. So they came up with the concept of Millennium Development Goals, 8 MDGs and all. We'll talk about it later when we talk of policy more. So word population. Why word population? Because when the human population increases, it puts a stress on human resources. You need more food. You need more, wherever the the economies are developing. You thrive on natural resources, so you deplete it to unbelievable extents with industrialization. And then with industrialization, you pollute. And then because there's no population, your food production and consumption is, so basically it leads to resource depletion. It also leads to release of pollutants in various spheres, biosphere, various spheres. So whether it is in atmosphere, whether it is in land, whether it is in water. So these are the burdens that we put on Earth. And collectively, we found that, if you have to, there are certain limits to growth. If you keep on developing, keep on consuming the Earth's resources, then at some point, you're going to cross that threshold, which keeps the Earth systems in balance. And there's a famous paper by Rockstrom, 2009. In fact, there's some 28 authors which came up, a collective paper by these authors. And the paper is called Planetary Boundaries, Exploring the Safe Operating Space for Humanity. So they identified 9 planetary boundaries. They said climate change, oceanic climate change. So we've seen how weather is changing. Statistically, we can observe it is changing. Ocean acidification, because whatever pollutant we give out in any water body, eventually it lands up in the ocean. And with the highly acidic nature of pollutants, it has resulted in ocean acidification. Ocean acidification, finally, it affects your thermo-aligned circulation also. Then your aircrafts and the PFCs and the gases that we were using in refrigerants and various other gases, they're depleting our ozone. Then we have the use of excessive use of chemical fertilizers. We are disrupting the phosphorus and natural cycles. Then we are, with our urbanization, with our development, we are the rate of biodiversity, because we are reclaiming land. The land use patterns are changing. The way you're using water system, aerosol loading, chemicals. So there are basically 9 planetary boundaries that were identified, and they say there are thresholds. I will not go into detail. You can read more about it. We'll provide you links later. They decided thresholds for all these 9 planetary boundaries. And they say when your values are somewhere around the threshold, if you exceed it, then that will basically lead to disruption in the natural cycles, various interactions that take place between the atmosphere, between the cryosphere, between the land and the biosphere. And that is going to disrupt the process. And how is it going to manifest? It is going to manifest in terms of extreme weather that you'll find changes in climate and extreme weather. So next, so this is a pictorial depiction. These are the 9 planetary boundaries. 2 have not been quantified. One is your atmospheric aerosol loading. Aerosol means, you see, certain chemicals that are there in the atmosphere that basically help. They act as for cloud formation. They act as I'm forgetting the term right now. So basically aerosols, they are favorable for more cloud formation. So atmospheric aerosol loading was not quantified. So we don't have a threshold value for that. And the second one was your biogeochemical cycles. So nitrogen and phosphorus cycles, 2 cycles, quantification was not done. And for all the other they have done. And of the 9 boundaries, 4 boundaries have already been exceeded. And unfortunately, climate change is one of them, because the threshold we had for our carbon dioxide concentration was about 300 ppm, parts per million. We are currently at around, we had exceeded 410 last year. Let's see what's the current value. So now what I spoke earlier also that, when we talk about weather, and from weather we derive climate, what are the factors? Which are the elements that we are influencing when we talk of? So wind, it will manifest later on, but because of the emission of greenhouse gases, you have read about the greenhouse effect. So the basic role of greenhouse is that you have incoming radiation, sun's radiation. What a greenhouse gas will do is it will absorb the incoming radiation. Now, if it absorbs more, if its concentration is more than what it is, it will absorb more heat, it will retain more heat, your average temperature will increase. Your average temperature increases, then it results in it impacts various other feedback loops. And then whether, depending on how high or how low is your greenhouse gas concentration, that will result in different types of manifestations in terms of climate. So what the greenhouse gas directly impact is the temperature variable in the weather. Now, because of that, other things, because of this temperature impacting other cycles, it gets manifested in terms of various significant weather events. What are the significant weather events? How does it manifest? You can have very heavy precipitation, you can have very heavy snowfall, because you have high retention of heat. That heat needs to be transferred to the upper latitudes. So you have severe cyclones, because why do we have cyclones in pre-monsoon and post-monsoon? These are massive systems. It's like a truckload. Say if I'm going by a 2-wheeler, I can carry only this much load with myself. But if I'm moving in a big jet carrier, if I'm carrying a truckload, then I can carry more heat. So you'll find all the cyclonic circulations that form close to the atmosphere, they develop into cyclonic storms. They carry huge amount of moisture. What is moisture? Latent heat, the basic fundamental physics that you've read in your school level. There's huge amount of moisture, there's evaporation, it carries all that latent heat. Some precipitation, landfall takes place, and you'll find none of the cyclonic storms they lose latitude. They always gain latitude. They always move away from the equator. So they're carrying heat, the equatorial heat, to the upper latitudes. And then the landfall takes place. There's huge amount of precipitation, and the entire latent heat is released there wherever the landfall or the precipitation takes place. So you have you have higher temperature, higher GHGs. I'm simplifying it. It is not as simple, but directly in terms of understanding simply is higher greenhouse gas emissions, higher retention of heat, you have higher temperatures, you need more heat to be transferred. That will be manifested in terms of severe cyclones. It is manifested in terms of extreme weather events. So you'll have cases of strong winds, you'll have cases of heavy precipitation, you will have cases of heat waves, very high average temperatures. This is a very simplistic correlation. And then how does the anthropologic influence, how do we use it? But how do we emit more greenhouse? Direct one is by, I'm not going into the other 9 planetary boundaries, other 8 planetary boundaries, because we influence in many other ways also. We've read it, we've already seen it, that, you know, we are changing the land use. Where there were forests, we're cutting it down. So your sink is going, because your climate are, they absorb carbon dioxide, your sink is gone. Freshwater use, then biodiversity loss, because wherever you have rich biodiversity, you have more vegetation, you have more, it acts as a sink. Aerosol loading, if you have, aerosol is still not quantified, but you have high cloud cover, so you have cloud cover. If you have higher cloud cover, it basically arrests the incoming solar radiation. So chemical pollution, it changes your water cycle, it changes climate change, ocean acidification, it changes your thermohaline circulation. Ozone depletion, you have, because you have ruptures in your ozone layer, so you have more incoming radiation. So it basically changes your energy budget, and this is how it changes. So you have use of fossil fuels. This is the primary way. We're only talking about anthropogenic influences in climate change. So use of fossil fuels, then industrial processes, you're releasing chemicals, you're releasing not only carbon dioxide, but other greenhouse gases. Agriculture is a major source of greenhouse gas emission. Your paddy and your cattle, in fact, cattle is also counted when you calculate emissions in agriculture. Your cows, and when they burp, so they release a lot of methane. Then waste, whether it is solid waste, it is liquid waste, they release methane. Then your land use change, we've read it, these are all basics. So this is how anthropogenic influences. Now this is a famous curve, if you have seen it earlier, this is called Keeling curve. And because when we talk about average carbon dioxide concentration, we say it has reached, I would think, if I can change it, isko minimize kar dete hain. Haan. So when we say that concentration of carbon dioxide has, the current concentration is 414 ppm. So which place are we talking about? We're talking about the average observations that are, the average, this is a representative which is taken as average. There's a place called Mauna Loa in Hawaii. Now, if you are aware of America, so somewhere around the southwestern side of USA, you have Hawaii Islands, which are deeply into the sea. There's no landmass far away from Hawaii. So you find that there was a scientist called Keeling, and Keeling had set up an observatory in Mauna Loa in 1800, I think 1960, because those were the initial 1957, somewhere in the 1950s. And there he started taking observations of carbon dioxide. So this is the first documented record, continuous record in Mauna Loa Observatory. And moreover, the location is such because there is no other interference from any other body, because there is no industrialization, little bit of industrialization now over Hawaii, but otherwise, when we're talking about 50s and 60s, there was not much infrastructure there. So they said, and intermixing of because of the circulations you have, wherever the greenhouse gas emissions are emitted, whether it is in India, whether in China, because of the atmospheric currents, they get all mixed up. So they said this is a good place to have a representative to take this as a representation of the global carbon dioxide concentration. So the latest, I think last year average November 2021, what they released was 414 ppm. And as you can see, from 1960 onwards, this is last year till 2020, gradually you can see that these emissions have been going on and on and on, and 410 was last year's average. And the rises and the falls that you see within this Keeling curve, these are seasonal changes, because winters may you have the fall of leaves, so your carbon dioxide concentration grows up. Spring may you have the new sprouts coming in, and the spring season coming on, so during the growth of that biomass, your carbon dioxide gets absorbed. So these are seasonal variations within a year, and what you see is the spread around, but you see that the trend is increasing. So this is how, in the last, what I was speaking about earlier, is within a period of 150 years, we have increased, the CO2 concentration have increased from 310 to 410. Almost 100 ppm has increased. So this is the anthropogenic influence. And now if you break down that, what is the breakdown of these gases? So we find that fossil fuel and industrial processes, they contribute about 65% of the entire greenhouse gas. So 100% agar aapka pura hai, so 65% is by this. 10 forestry and other land use is 11%. This you might question that why it is looking, why forestry is also a source here. But the thing is, when we talk of forestry and other land use, we take agriculture also into this. So eventually forestry and agriculture combined becomes a source, it is not a sink. Forest in itself is a sink, but forest and agriculture, a FOLU is the agriculture, forest and other land use, 11%, methane is 16%, and nitrous oxide 6%, F gases 2%. So this is the breakdown of the greenhouse gases, global breakdown. Which are the sectors which are emitting more? So you'll see electricity and heat. These are global figures. We go into country-wise, we'll go later on, maybe third or fourth day onwards. So electricity and heat production contribute 25%. Other energy uses, which are basically in the industrial processes, they contribute 10%. Agriculture, a FOLU sector, contributes 24%. So about 60% of your greenhouse gas emissions, they come from electricity and a FOLU sector. Energy, not electricity, energy and agriculture production buildings, transportation industry comprise the rest of about 35-40% of it. Now the thing is, if I want to understand, now I've seen that climate is there and climate change is taking place. This is how we are emitting gases, this is how we are emitting, this is how each sector is contributing. But how are they, if I want to make a change, and if I want to say which sector do I reduce, or if you've heard about Paris Agreement, which just came about 6 years back in 2015, they say the long-term goal of Paris Agreement is that we want to limit the heating of the atmosphere by 2 degrees Celsius by the end of the century, and make it more ambitious, try to limit it to 1.5 degrees Celsius. So if I want to say no, or understand that what steps do I take if I have to limit the global warming to below 2 degrees or below 1.5 degrees Celsius. So there's so many interactions. How do I understand? These are the interactions. It's so complicated. So you have incoming solar radiation. Now, how much is the cloud cover? That will decide how much irradiation is coming. How much is the aerosol? That will decide how much cloud formation is there. Then you have ice and atmosphere interactions. Then you have some volcanic activity. Why volcanic activity? Because volcanic ash has got a lot of sulfur dioxide. Sulfur dioxide has got a lot of, it is a favorable aerosol for cloud formation. So volcanic activity, you have biosphere, whether the land surface is covered by. So all these combination, and in between you have human influences where we are emitting more by our various processes. We've seen which sector is emitting more. Now there's so many complications, and if I want to understand that if I want to achieve this, I want to limit warming up to this. Now, which process do I tweak? What steps do I take at what level so that I reach this goal? So what we do is there are such complex interactions that we try to model the Earth system, because the computations are going to be so many, and the equations with there. This is basically physics. So the equations are going to be so many that it is impossible. We try to depend on computing and try to understand that. So what we do is we model the climate system, which includes atmosphere, land, ocean, ice, and biosphere. There are various variables. This is in itself is a specialization, and I will just give you a brief overview also because I don't know too much about it. So what we do is that we try to model, there's an atmospheric GCM model, global circulation model. What we try to do in this, I will just go back once again. This we saw, that this is how the global circulation, atmospheric circulations take place. So you have observations scattered all over. So if you talk about these heights, say 800 meters पे कितना wind है, 1.5 kilometers पे कितना wind है, 3 kilometers पे कितना है, 9 kilometers पे कितना है. All these observations are available. All these observations are taken. Wind observations are taken minimum twice a day. And if I can provide you links later on, and you have a huge network of observatories. So what we do is that we try to incorporate this atmospheric circulation into the global circulation model. Ocean circulation model we try to incorporate the thermohaline circulation. So let me go back. It is a little bit of. So what we try to do is we have an atmospheric GCM or an atmospheric global circulation model, which tries to incorporate all those cells. You have atmospheric low, your polar high, your subtropical low, all those things. Then we have a ocean journal circulation model. And there are many parameters you can see, because atmospheric, if you look at ocean layers, so top 1 kilometer is about the sun's radiation is able to heat only top 1.1 kilometer. Rest of the heat doesn't reach the lower layer, so they're cold layers. So the ocean journal circulation model tries to incorporate the physics of the thermohaline circulation. Then what plays a major role is how your land is distributed, whether you have mountainous region somewhere, whether you have it is a coast, because that will affect your heating that will affect your wind flow. So they try to do a mapping of the topography that is also incorporated, and then they are integrated, and then various equations are integrated into the modeling, and then they do certain parameterizations, which are basically some simplification of certain processes, and then they try to run a model. Then they say, okay, let us run a model. There's a global circulation model which says, okay, all over the world this is how it's going to be. Then there are regional circulation models also. Regional models may say, suppose over Asian region, or say suppose over American region or Latin American region. So there are different models, different groups. European the ECMRF, European Center for I'm forgetting the name, but Europeans are very strong in this, so they have their own model. Copernicus program they're running, so the huge observation. So what they do is they first try to model it कि ऐसे ऐसे होता है, एटमॉस्फेयर में इस तरह से हवा बह रही है, ओशन में इस तरह से पानी बह रहा है, इस तरह का लैंड मॉडल है. Then what they do is they try to put in the historical data. When you talk of climate modeling, you basically put the historical data. 30 years, 40 years, decades of data is fed in, because it will focus for another 30 years, 40 years, 50 years. Similarly, when you do it for weather systems, short range forecasting, what we do is you'll find AccuWeather and many other this thing running, giving you forecast that वीकली फोकस्ट क्या होगा, संडे को 4 बजे बारिश होगी कि नहीं होगी. वो दे ट्राई टू रन इट ओवर विद द ऑब्जर्वेशन. दे फीड इन द ऑब्जर्वेशन. जो ऑब्जर्वेशन अभी चल रही हैं उन ऑब्जर्वेशंस को फीड करते हैं. इन क्लाइमेट मॉडलिंग सिस्टम the data that is fed in is the climatological data. So the complicated, the huge physics and mathematics that goes into it. They try to integrate the factors of how much heat is coming in. So the incident solar radiation, which varies. Then whether it is closeness to water bodies. Why water bodies? Because your humidity plays when you talk of weather is what? It is temperature, humidity and pressure, interplay of these three parameters. So whether there's a water body, they try to map the terrain. Then altitude wise, it has got a depth, different layers, ocean temperatures and current. They are manifested in the ocean GCM. Then land cover. Why? Because land heating change ho jayegi. And then atmospheric composition. So this is talking very simplistically. These are the factors. Basically, the interactions are the major interactions they try to feed in, and then they try to model the system. Now, the latest that is going on currently is there have been several models that have been done. The latest that has come up is the coupled model, because CMIP is a term that you'll hear whenever you talk of projections, because what climate model does is it says over a period of time, last 100 years, 2 years, 100 years, 150 years, the weather climate has behaved like this. Now, these are the variables we feed in. If we say GHG emissions are itna, or GHG emissions are whatever quantum we're talking about, then what is going to be the future in next 30 years, next 50 years, next 100? So generally 30, 50, 80 years tak ye model run ke, it will give you a scenario. It will give you a projection for the future. So what CMIP does it, what this is basically has been, IPCC ki reports ke duran this thing came up was, they came up with a coupled model intercomparison project, where what they do is, it is currently in the 6th run. What they do is different models which are being run by different groups. So what they do is they try to compare all those scenarios that are given, and all the scenarios that are given, and what is done is that it allows, say one model is giving with the same parameter. If you give the same inputs, that we are going to change the GHG concentration like this is the socioeconomic pathway we're going to follow, and then they say how this model is behaving and how the other model is behaving. And there are about, if I'm not wrong, some 40 to 45 models which are being used, and different modeling groups which are using, and then they try to compare different models, giving them the same inputs, and they see whether these models agree or disagree, and on basis of that those simulations are run. Now, I will first cover this because we are currently in the IPCC AR6. AR6 assessment report, 6th assessment report, IPCC 6th assessment report. They have already taken out special reports. The 6th assessment report, I think, is going to be out somewhere by January or February. And what IPCC does is, about 6 to 7 years, they come up with the assessment report. And what the assessment, they don't do a research of their own. How much time do I have? They don't do research of their own. What they do is, whatever is already peer reviewed and published, they collate all the research, and then by collating all their research, they say that what the research is saying. So in the 5th cycle, AR5, they came up with 4 RCPs, or the representative concentrated pathways. Those 4 pathways are these: 2.6, 4.5, 6, and 8.5. These figures are basically the radiative forcing. Radiative forcing means how much, if you talk of energy budget mein kya hota hai, incoming solar radiation is this solar radiation is coming in, and the land absorbs it, the water absorbs it, the ice reflects it. If the cloud is there, if the aerosol is there, that will play depending on how much amount is it. Then various processes, plants will absorb heat or yoga, all those processes करने के बाद finally they say that this much radiation, this much heat is basically absorbed in the earth system. Now how much heat is absorbed finally is called a radiative forcing. If the radiating forcing is low, yani RCP 2.6 means it is that scenario in which the heat absorbed by the earth is less, or if we can say it is a low GHG scenario. So they had RCP 8.5 is the other extreme, where they say कि हमने कुछ नहीं किया, जिस तरह से चल रहा है business as usual. That is where you have the highest concentration of GHG. But whatever is the current rate of emission, those trends are going to continue. So your radiative forcing is going to be high, or the heat the earth is going to be retaining is more. So they came up with 4 scenarios, and with those greenhouse gas emissions they came up with, agar itna hoga to temperature itna padega, itna hoga to temperature itna. 4 RCPs they came out. Now what novel thing they're trying in AR6, the current assessment that is going on, or is in final stages, country reviews are going on currently. So they've come up with a new set of emission scenarios in which they've integrated shared socioeconomic pathways. Socioeconomic pathways, what are these? When we talk of, say, suppose we say the way business as usual means what is going on currently, the way, what is the status quo right now. Now then we say there are different, every country has got its own development agenda. Say suppose if you read the first climate Rio agreement that India had done, India said for us, poverty alleviation is one of our prime, core goal. Because India, if you look at the global GDP and if you look at what the Indian GDP is, if you find in terms of per capita, this thing, India, there's about, if I'm not wrong, last hamara census mein about 23 or something, if I'm not 23-25% of our population is below poverty line. So we say we have a huge population that is living below poverty line. So poverty alleviation for us is a prime goal. So we basically want to, it is from there that the concept of climate justice came in. So we say that we have to grow. We have, to the developed world, the stage of development that you are right now, we are way behind. We joined this development wala jo game hai, we joined, we are the late joiners to the party. So we still have a huge trajectory to cover in terms of pulling our population out of poverty. So now if we say that we want to develop, we have a huge population which we have to take out, we have to increase our per capita, we're talking only about economic development right now. But then we want to improve their living conditions also. There, agar aap MDG ko follow kar rahe ho, so there are health parameters, there's so many parameters, infant mortality, mother mortality, education. So there are various socio-economic factors. So what the new models they do is they try to integrate the social economic pathways also. We say that our GDP has to be, say suppose at 6%, or say our poverty has to be, currently we are at 25-27%, our poverty say is to be at 10%, or we say we want to pull out everybody. Abhi SDG mein to hum no poverty goal mein chale gaye abhi. So what they do is, in addition to the greenhouse gas emissions, they also, and which are the environmental parameters, they also take the other social and economic parameters. So this is a new thing that has come up in your IPCC AR6. So these are shared socioeconomic pathways. There were some models which are running earlier, just socioeconomic hai, but this is something new. I have to read more about it. So broadly, what I can say is that IPCC 6 is going to be more based on the concept of climate justice also, integrating climate justice. We can say, okay, if these are the social economic parameters that you want to improve, in addition to the environmental parameters, then these are the different scenarios that are available to you. Now, we've spoken about climate change impacts we'll cover tomorrow, but if you see who is hit the most by the impacts of climate change, going purely by the color coding, the yellow color is the developing world, the green color is the developed world. So you find, if you see the per capita emissions of these countries, global per capita emissions, so their global per capita emissions are somewhere around the range of 20 to 30 times of the average global per capita. So simply speaking, agar hum average 1% consumes, say suppose 1 unit, and average American consumes about 17 times more than that. India is below global average. India is about 0.6 or something below global average. So this year, less than 25% of the world population, not population or the major economies, they emit more, and the impacts that are faced are by the economies which are still developing. These are basically, these are the ones who have emitted more, and this is the population that is facing the impacts of their emissions. So this is the developed and the developing divide, and this has been the per capita emission, the historical emissions and the per capita emission are strong points on which the entire climate policy debate is internationally focused on. We'll talk about it later more, because climate change itna zyada hai, we'll not be able to cover everything, but you can just see the ones who emitted more during the last century, and these are the people who are affected more by the impacts of climate change. Now, what is being done about it broadly? What has been done about it till about 2000 may UN, it came up with MDGs, Millennium Development Goals. They said, let us give ourselves 15 years, 2000 to 2015, 8 goals, and over a period of 15 years, the impacts of climate change, they became so evident. There are so many, they revised the goal, and now they've integrated. There are 17 SDGs now, 13 SDGs climate action, combating climate change, or more focused on climate on taking action that translates into a positive affirmative action in climate change. So this is internationally what is happening, how it will flow later on. Climate, when we talk of climate policy, yahan se it starts, but not exactly with SDG, but with international action, what is going on, and from there it flows down, and then it flows down quite a bit. How much time do I have? 7:49. I exceeded 9 minutes. This is a motivating quote that Pratiksha has put up. Please read. I will not read it. With this, I have finished my part. You have any questions? Please feel free to ask.
Hello, ma'am. I hope you can hear me.
Yeah, I can hear you. Yeah.
Thank you, Abha, ma'am, for the class. I think it was very much detailed and short at the same time. So thanks so much for that. I have actually 2 questions. When I saw the presentation, we come to know that every country, they have like they use these models that are verified and approved by the whole world. Okay, you said that the Europe is more sophisticated and they have their own models. Okay, very good. I want to know which government authority in India is liable to make these models, because as far as I know that we all the countries of the world who have signed up to the Paris Agreement, they have to submit like their emissions and their NDCs every year. Like NDC concept came in 2015 something, but uske pehle bhi har saal hum log को हमारे emissions वगैरह submit करने पड़ते थे. तो कौन सी government authority है जो ये करती है India?
See, not every year. There are two. So your question has got 2 parts. First thing is, you're talking about which is the authority which deals with climate modeling in India. Have I understood it correctly?
Yes.
And second thing is that GHG emissions ka reporting in terms of where is the capability for GHG reporting in India. So the first part is climate modeling mein what Indian Institute of Tropical Meteorology, IITM Pune. That is it comes under Ministry of Earth Sciences. It's what do you call it? Independent institute. It is advanced in terms of climate modeling. In fact, we recently it has come up with a report of assessment of climate change over Indian region. They were working on CMIP 5, because what happens is climate modeling mein, other than all models, because observations are slow. UN has got a global watch program. Gloss ya kuch naam hai uska. I'm forgetting that there's a global observation watch program. So what happens is, जितनी observations India में होंगी, जितनी observations Pakistan में होंगी, wherever in the world, it is internationally shared through UN. So it is not that India will keep the data with us or some other country we are friendly, not friendly will keep. So the entire set of current weather observations are shared real time across the world. UN is the repository. India Meteorological Department is the repository for weather observations. They have a national data center for because weather jama hota rahega, usi se to you will take out climate, no? So IMD is the repository for weather observation. So they have the archival data. Using that archival data and to use it for projection is IITM Pune, Indian Institute of Tropical Meteorology. So they run models, and Param, in fact, if you look into the history of how meteorology, I have a soft corner because I'm a meteorologist, by training. So the first supercomputer that came in India, it came to IMIT, Param. And अभी
Okay.
कुछ नया आया है, मतलब इसकी processing power is in some TB and पता नहीं whatever they call now, number of zeros I don't know. So they are running the model here, right? In IITM Pune they are running the model. So India के projections हैं, IITM Pune is the authority, but the model का only drawback is because terrain becomes very important. You know, I'll tell you why. Because तुम जा रहे हो and तुम्हारे पास, if you look at Indian topography, हमारा entire monsoon is because the Himalayas are there. Had the Himalayas not been there, तो हम winters में बहुत cold हो जाते, क्योंकि ऊपर से पूरा जो cold air mass है हमारे में आ जाता, और जो हमारा साउथ वेस्ट मानसून का जो लोड मॉइस्चर बेरिंग करंट है, वो Himalayas, they act as a barrier. 5.4 kilometer average height. Imagine a height of 5.4 kilometer average height. Average height है. It's a big barrier. So topography mapping becomes very important. Now the biggest limitation in India is that जो ये global models हैं, इनमें पूरे globe की topography map नहीं है. So they have, you know, European region is very well mapped, US is very well mapped, most of the Western countries are well mapped. Indian topography is not very well mapped. So when you run those models, so there's some little bit of uncertainty that comes in. But in spite of that, because, you know, so when we spoke about, अगर मैंने इस पे slide रखी होगी, तो which are the factors that you take in? See these factors, no? So you take mountain barriers, altitude, your land cover. These are important factors in your model. So हमारे केस में बस limitation ये है कि हमारी पूरी terrain map नहीं है. Otherwise, IITM is a good authority. In fact, if you look into IITM has recently come up with this assessment of climate change over Indian region, climate data, not climate projections. Now, the second question about GHG reporting, greenhouse gas reporting. So what it does is, we'll talk about it later also, because it comes into climate, the divide that you're talking about, developed and the developing country. So when the Rio Convention came up in 1992, they said कि you have to recognize that हम तो industrialize ही नहीं हुए थे in the developing world, तो अभी इसीलिए we are developing ना. So they had a clear cut division where they said, okay, these are developed countries which are called NX1 country, NXA country, और जो countries इसमें नहीं, they are basically USA and European countries जहाँ industrial revolution पहले आ चुका था. The rest of the countries which are not on those NX1 are non-NX1 countries. Means जो उस list में नहीं है, वो उस list में नहीं है, वो सारे non-NX1 में आते हैं. So all non-NX1 are developing countries. So now the developing countries say, you want us to report, but you have to fund us. हमारे पास तो पैसा नहीं है, we're developing. We don't have capacity. Not only पैसा, we don't have capacity. So the UN has made agreement that they sanction projects wherein they say, okay, for this reporting, we give you this much amount of money for this much period of time. That process is called NatCom, National Communications. So every developing country, every 5 or 6 years gives their national communication. In fact, I have worked for about 2 years in the third NatCom, India's third national communication. And then with Paris Agreement, even before that, they came up with the concept of biennial update report. So जो NatCom जाता है, जिसमें आपकी other than GHG inventory, आपने mitigation में क्या किया, adaptation में क्या किया, capacity क्या करी, आपकी technological needs क्या हैं. There's a huge book about 200-300 pages. Look for initial NatCom, or we'll put links. So Ministry of Environment, Forest and Climate Change, MOEFCC, is the nodal agency in India. And MOEFCC has got a NatCom cell, NatCom project में जो लोग काम करते हैं. Fortunately, I was one of, about 3 years back, I was one of the member of the team. And what they do is that they calculate they don't calculate, basically we have a network called INCA network, Indian National Climate Change coordination है कुछ है, मैं एक word में भूल रही हूँ, but इनका network में क्या है, we have about 200 institutions including most of the IITs, most of the IIMs, all the central research institutes जो आपके CSIR labs होती है ना. So we have Institute of Mining and Fuel Research. So what we do is sector-wise inventory estimation we give to dedicated institutions who are doing research on that. So they calculate the inventory and they give it. So the NatCom cell basically coordinates the entire, it does a research management part. It doesn't do research, it does research management part. And then with whatever funding is available through, so the Global Environment Facility or GEF, जो कि global एक fund बना रखा है जहाँ सारी developing countries pump in करती हैं पैसा, थोड़ा बहुत developed countries भी करती हैं. They sanction projects, that money goes to developing countries. That money is used up to fund your NatCom process. And इसमें capacity building भी होती है. They build capacity, they train people. And then those NatCom, and every 2 years you report a short report in which mandatory part is your greenhouse gas inventory and your mitigation actions. So अभी third BR हमने अभी दिया है. I worked with the second BR, third BR हमने अभी दिया है. If I'm not wrong, we submitted somewhere around January or February to 2021. We submitted our third BR. So we'll provide you links. Otherwise, go to the MOFCSC site, Ministry of Environment ki site mein jao and look for publications. They are all publications which are given. So for modeling, IITM Pune under Ministry of Earth Sciences. For greenhouse gas inventory, it is NatCom project under the Ministry of Environment, Forest and Climate Change. Have I answered?
Thank you so much, ma'am. Yes, ma'am, you answered my question very well. So just last thing, this report, the new report on assessment of India's climate change, that is by IIT, IITM Pune.
IITM, Indian Institute
Okay,
of Tropical,
IITM, sorry.
Indian Institute of Tropical Meteorology.
Tropical. Okay, and that's the report is like, is it available for everyone
Yeah,
online?
yeah. I have been I should not be bragging. I have worked as a science communication expert for this report. In fact, I'm an author for
Okay.
chapter 1. I have a
Okay.
PDF for everything. I'll share the report. Otherwise, links Springer may available on payment, but I'll share my copy. I will
Thank you so much, ma'am.
end
Thank you so
of
much.
the course.
Thank you so much, ma'am. Thank you.
Any other questions? We have 2 minutes. I think Pratiksha is our moderator. How much time she can give?
Yeah, it is किसी को कुछ प्रॉब्लम है, किसी को कुछ डाउट है तो बता सकते हैं.
I just have a query. It's just that I didn't get the RCP part well, representative concentration pathways. It was a little technical for me.
See,
If we can go back.
it is actually technical.
Yeah.
Let me go back. See, what happens is, let me first take you here. So, let me first take you here. ये तो ऊपर आ जाएगा. If you see the interactions, you've understood that there are a lot of cycles. You must have studied in senior secondary. ना carbon cycle होता है, water cycle होता है, hydrogen ये क्या नाम, phosphorus cycle होता है, nitrogen. There are many cycles that which are going on. So Earth in itself is one cycle doesn't run in isolation. So Earth, when you talk about Earth system, it's a closed system. Closed system, you understand, na? मतलब Earth में closed systems, open and closed systems, you understand.
Yeah.
So
Yeah,
Earth
yeah,
is a
I
closed
do.
system. So Earth is a closed system. And within the closed system, what we have is a systems approach. Systems approach means ये नहीं कि ocean cycle है तो atmosphere को affect नहीं करेगा. All these processes, they interact with each other. So if you perturb one cycle, if you जिसको बोलते हैं ना छेड़ दो एक साइकिल को, तुमने यहाँ पे ज्यादा GHG डाल दिया तो तुमने क्या कर दिया, एटमॉस्फेरिक हीटिंग बढ़ा दी. You put pollutants also, so that has finally gone into your ocean. So your ocean acidification. So basically what you've done is you've perturbed those cycles. And because of that, everything gets, everything else affects feedback mechanisms के through हर process दूसरे process को affect करना शुरू कर. This is called systems approach. It is not a standalone system. Any cycle is not standalone. Everything interacts with everything else. In fact, read about Gaia theory. I will not be able to cover it here. Gaia theory भी it considers Earth as a whole organism. Is that Earth organic है बहुत. ये नहीं कि land dead है और ये dead है. Earth in itself is it treats the Gaia theory. That is besides. The thing is, so what we do is we try to integrate all those things in our models, and models में हम उसकी अलग-अलग processes को भी try to replicate, ठीक है? And how does computer work? It works on solving equations. So you feed in all those, बहुत सारी hydrological equations हैं, ये वाली equation है, gravity कैसे काम करेगी, अगर यहाँ पे density बढ़ गई तो circulation पे क्या फर्क पड़ेगा? All those mathematics and physics, it goes into it. Now the thing is, if I say कि यहाँ पे आ जाते हैं, are you able to see my screen? मैंने बड़ा नहीं कर रखा है इसको.
Yeah.
है ना? So RCP में क्या करते हैं? हाँ, so what IPCC does is IPCC हर 5-6 cycle में एक assessment report निकाल देती है. It is called, पहले FAR बोला था first assessment, वो करते करते 4 और 5 के बाद 3 के बाद वो AR4, AR5, AR6 में आ गए. AR6 is currently in its final stages. The country reviews are going on. So what in AR4 they introduced a new thing. They said that if we have certain models, and if I want to say कि अगर, because the entire game, Earth का entire game क्या है? How much, had there been no interference, how much heat should the Earth should have absorbed? मतलब अगर हम ऐसे बोलते थे, अगर Earth में greenhouse gases नहीं होती, had there been 0 greenhouse gases, the average temperature of Earth would have been -19 degrees Celsius, inhabitable. Human life के लिए possible नहीं था. Because of the greenhouse gases, because of that क्या बोलते हैं, greenhouse effect, the average temperature of Earth is +15 degrees Celsius. Now we have increased that concentration of greenhouse gases. So the average temperatures are going higher. Okay? So they say that what will be the future if my heating is positive radiative forcing. Radiative forcing मतलब कितनी heat Earth ने absorb कर ली. It is measured in terms of watt per meter square. Watt is energy, meter per square is area. Per unit area Earth ने कितनी energy ज़्यादा absorb कर ली. So if your heat absorption is 2.6 watt per meter square, what is going to be the future? Now this 2.6 should not be confused with 2.6 degrees Celsius. This is 2.6 watt per meter square extra heat that the earth is retaining. वो किसकी वजह से retain करेगी? Because of a certain greenhouse gas concentration. Is it clear? Tell me first.
Yeah.
है ना? So from the normal, जो मतलब जो तुम्हारा actually without anthropogenic interference जो scenario था, उससे you have increased the greenhouse gas emission. उससे because of the heating, it is retaining certain extra heat. So if your heating is if your heat retention it is not heat retention is not the right. If your radiative forcing is 2.6 watt per meter square, what is going to be your future? So then it came up with scenario. These are called representative concentration pathways. If this much heat is retained, then मतलब basically इतनी कार्बन डाइऑक्साइड रहेगी, इतनी रेडिएटिव फोर्सिंग रहेगी, तो मेरा फ्यूचर क्या रहेगा? Then it comes up 2.6 सबसे वेरी स्ट्रिंजेंट पाथवे होता है. इसका मतलब जब हम ज्यादा GHG एमिट नहीं कर रहे, so you don't need to adapt more, because अगर तुम ज्यादा हीट एमिट नहीं करोगे तो तुम्हारे क्लाइमेट चेंज इम्पैक्ट्स will not be that severe. Getting my point?
Right.
है ना?
Yeah.
So they came up with RCP 8.5 is the scenario in which they say, like it is going right now, whatever we emit, if we take no steps, it is called BAU, business as usual. If we take no steps, let the emissions go as they're going, let every country emit as they're emitting. So then you catch up with on trends. By last 10 years में ऐसी growth थी, ऐसा trend होगा. So if they continue to behave like that, if they continue to emit like that, your radiative forcing is going to be around 8.5 watt per meter square. Then what the future is going to be? So these scenarios, they basically focus. They say कि इतना temperature बढ़ जाएगा, इससे इतनी flooding हो जाएगी, and then इस flooding से इस जगह में ज़्यादा prone होगा, which region? So RCP scenarios, basically they give you the future if your heating is this much. So I have just mentioned RCP scenarios in itself is a huge bulk. If you have to read about it, it will tell कि Indian region is more prone, African coastal regions are more prone, America के northern regions are more prone. तो वो scenario का पूरा description है. Abhi I just mentioned that there are scenarios. Every scenario comes with a description that what will happen if this much heating takes place. So read more about the RCP scenario. It will tell you how the future is going to. It's a scenario. It's like if I paint a picture, if I say, if I, you're getting my point. So
it's like, is it just like the future scenario? Current का कोई है?
Current तो scenario की जरूरत ही नहीं. Current तो हम देख रहे हैं ना.
Okay. So how was that calculated and how is that tracked?
That is done by climate modeling. That is done by modeling. Okay,
this is just for the future. Okay, the prediction. It's like predictive analysis.
Modeling is done two ways. You can do a forward modeling, you can do a backward modeling. And backward modeling is a way of, say, suppose this is 2020. Let us 21 छोड़ दे. Let us take 2020. Now, if I say 2020 में, this is our emissions. This is how we are doing emitting, and हम इस sector को इतना कम करेंगे, जैसे हमने RE में इतना target reach कर लिया, whatever. ये सब करने के बाद हमारा फाइनल ग्रीन हाउस कॉन्सेंट्रेशन इतना हो जाएगा, या हम ये हमारा अब तो सोशियो इकोनॉमिक पैरामीटर्स भी आने लगे, तो हमने कुछ एक स्टोरी लाइन बनाई. इनफैक्ट व्हेन यू टॉक ऑफ मॉडलिंग, ऑलवेज टॉक ऑफ स्टोरी लाइंस, कि हम 2020 में ऐसा है, वी विल टेक दीज स्टेप्स इन नेक्स्ट 10 years. सो 2050 में वेदर क्लाइमेट कैसा होगा. So what it does is you feed those parameters into the climate model. It will give you a future. It will tell you how it will be. It is a set of values which are to be interpreted. So it will say GDP will be this much, it will be this much, your this area models will run. वो तो तुमको सब चीज के impacts दिखाएंगे, precipitation दिखाएगा, इधर temperature का range दिखाएगा. It has got a certain uncertainty built into it, but it will give you a future scenario. And then they say कि अगर हम इसको ऐसे नहीं करके हम इसको ऐसे change कर दें, so you have a very stringent scenario, you have moderately stringent scenario, you have business as usual scenarios. So modeling, what it does is, अब मैं how do I give you an example which is, you're getting my point. मतलब अगर मैं if I do this now, how 2050 will be, how 2100 will be, how next 20 years, how the climate will be. And it is not only climate, it will give you the entire spectrum. कि यहाँ पे precipitation ज़्यादा होगा, यहाँ temperature की range. We usually talk in terms of temperature, precipitation, humidity. तो ये तीन चीजों का क्या, टेम्परेचर कहाँ ज्यादा हुआ, प्रेसिपिटेशन कहाँ ज्यादा हुआ. प्रेसिपिटेशन में आप स्नोफॉल, रेनफॉल सब ले लोगे. साइक्लोन्स कहाँ पे ज्यादा बनेंगे, वो आपको एक तरह से एक्सट्रीम वेदर इवेंट्स का फ्यूचर बताएगा. जैसे हम कहते हैं ना फ्यूचर बता रहे, तो वो मॉडलिंग में आप यू फीड इनटू दोस पैरामीटर्स एंड यू सी, से सपोज आई डोंट अरेस्ट my emissions, then 2030 में what will I, you'll say तुम्हारे temperature will go up by 4 degrees Celsius. Now if your temperature, all the calculations the model does, If my temperature goes up by 4 degrees Celsius, what will be the state of my glaciers? If my glaciers have melted this much, what will be my sea level? My sea level will rise. What will be the availability of fresh water? Now, if you are, because Himalayan glacier has got a big role to play in your monsoon. जब हम वो एल नीनो ला नीना अगर तुमने टर्म्स वो फॉलो किया होगा तो दे फोकास्ट इंडिया मेट्रोलॉजिकल डिपार्टमेंट फोकास्ट मानसून कि इस बार हमारा एक लॉन्ग पीरियड एवरेज का फोकास्ट देते हैं अप्रैल के मंथ में बताते हैं कि जून में हमारे इंडिया में कितना मानसून होगा सो द गवर्नमेंट ऑफ इंडिया डज द बजटरी एलोकेशन एज फॉर दैट इफ दे से कि विदर्भा में कम होगा हिमालय इधर ज्यादा होगा उधर कम होगा ये दिस इज ऑल डन ऑन बेसिस ऑफ मॉडल्स वो वेदर प्रेडिक्शन है बिकॉज दे डू शॉर्ट टर्म फोकास्टिंग climate systems they do in terms of decades in terms of 30 years 40 years 100 years.
Got
See,
it.
it is
Thank you so much. Yeah.
but see this I know this is too much to gather but this is how it is.
No, it's very
Yeah.
much clear to me now. Great explanation. Thanks.
Everyone, if you have any another queries or something, you can write it down on Slack and please talk on Slack if any problem occur. And अगर ज़्यादा fast हो रहा है session कैसे चाहिए आपको वो भी बताना because हमें आपसे idea चाहिए कि हम कैसे आगे जाए, right? So yeah, that's it. 8:10 होने वाले हैं 2 minutes में तो हम यहाँ पे एंड कर रहे हैं अगर कोई क्वेश्चन है तो स्लैक पे लिख देना अदरवाइज फीडबैक फॉर्म सेंड होगा और ये प्रेजेंटेशन एंड वीडियो आपको व्यू करके ऑप्शन में दिखेगा ड्राइव में आ जाएगा आपके कल तक मैं कर दूंगी ये सब तो ठीक है sayonara then thank you so much for coming to the webinar or session.
Yeah, and one more thing, go through the presentation because Pratiksha has planned few questions for you. So the first thing we start tomorrow morning are few questions. It is going to be some MCQs. So just go through just to get an idea whether you understood it correctly or not. Okay?
Yes, thank you so much. And if the topics are really tough, then we are going to send you some, like there are a lot of jargons. If you can see, like I'm from the environmental science, then I understand RCP, I understand lot of things, but अगर कोई jargons आपके मतलब दिमाग में stuck है कि इसका मतलब क्या है, हमें वो भी बताना. Abha will simplified it and we will send you the document next day onwards. ठीक है?
And today's session was because this was about the basis of climate change. So there's a little bit of science that goes into it. Abhi, when we come on to impacts and all, then they're not going to be too technical. And policy to फिर technical बहुत कम हो जाएगा. So I think the toughest session in terms of technicality would have been today for those who don't come from environmental sciences background.
Yeah, true.
Okay.
Okay, then Abha, thank you so much, everyone. Just
Thank you,
leave
ma'am.
the meeting.
See you. Bye.
Thank you. Thanks a lot. Great.
See you.
session.
Yeah.
Bye.
Thank you.
Thank you so much.
We can close the meeting and stop the recording.
Yeah, Arihant, you can leave the meeting if you want. Arihant?
Yes.
Yeah, thank you. Thank you so much. Hey, Abha, hi. Actually, two things. You're going too fast. From the start, you were like, बहुत ज्यादा फास्ट हो गए थे बीच में एकदम स्लो डाउन हो गए थे वो बहुत अच्छा था फिर आप मॉडलिंग के टाइम पे फिर से फास्ट हो गए थे तो मुझे ऐश्वर्या अतुल एंड 3 लोगों का मैसेज आया था कि मुझे समझ में नहीं आ रहा है तो मैंने उनको बोला कि शी विल स्लो डाउन अदरवाइज आई लेट हर नो द नेक्स्ट सेशन से थोड़ा स्लो जाना क्योंकि 2 पीपल है जिन्होंने मुझे ये भी बोला कि हम लोग साइंस बैकग्राउंड से नहीं है तो टर्मिनोलॉजी नहीं समझ रहे मैंने बोला शी विल एक्सप्लेन इट टू यू जस्ट वेट अप एंड देन हाँ वो रितु को बाद में समझ